Welcome back to Pop Goes the Stack, the show that dissects emerging tech with all the finesse of a root cause analysis after a 3 a.m. pager alert. I'm Lori MacVittie. Let's do a postmortem. So, for the last year, the industry has been obsessing over prompt injection. Every vendor demo involves clever prompts, clever filters, clever guardrails. They're all designed to stop someone from tricking the model with words. There's just one small problem. The model doesn't actually see the words. It sees tokens. Don't worry about the difference. We're going to get into that because it does actually matter a lot, okay? But what it means is that all the shiny prompt filters everyone keeps building are basically airport security searching your luggage. The attacker's still walking straight onto the plane through the cargo hatch. So 2 recent papers, Adversarial Tokenization and TokenBreak, which sounds way cooler, honestly, make this painfully obvious. Attackers didn't have to beat the model, they only have to beat the tokenizer. So they skip all sorts of things and guardrails. They do terrible things to your model, which is what we're all trying to prevent with prompt injection solutions and things we call guardrails. But let's step back a minute because we've got a whole lot of things going on here, including what's a token? Why does it matter? Why is that different than prompts? Firewalls, guardrails, and all sorts of security. So to break it all down, we've got, of course, our co-host, Joel Openclaw Moses.
Oh, no.
Well, you thought I was going to forget that? No, you've been branded, sir, forever.
I've been replaced by an agent. Look no further than that. Good to be here, Lori.
Absolutely. Excellent. And we've got an architect who's really cool and knows all this stuff. Elijah, welcome.
Nice to be here. Thank you.
Wonderful. Well, who wants to start and break it down? Joel's read the papers. You've read the papers.
Absolutely.
Somebody break it down.
I think it's most useful to describe what the difference is between, or what the relationship is between the prompt and the tokens that the model actually executes, because it doesn't execute on the text, does it, Elijah?
No. The paper uses an example of tokenizing the word penguin in 2 separate ways. Right? It starts with, you can tokenize with a P and then ENGUIN as one variation, or peng and then UIN as another token, as 2 separate tokens. So you get one word, but 2 tokens tokenized in 2 different ways.
Right. And when you send that text string along and the tokenizer grabs a hold of it, it tends to want to follow one particular path as guided by the fully assembled model. But that doesn't mean that is the only path it could follow. That's kind of the implication here, that one word can have 2 different paths. And that's what's causing this particular type of difficulty with the models, right?
Yeah. It's really at the model level, and the attack is, you're simply just re-tokenizing requests, and you're not changing the underlying natural language that you're feeding into the tokenizer. It's the same natural language you're feeding in, but you've changed how they essentially have segmented the text you're feeding in the model.
Some of this, it helps, I think. I mean, you're talking and I'm hearing things like digital search trees and graphs. Like when you start, right, if you've ever written a B-tree index for a database, right, and you're looking for certain words, things like that, how it falls out, like P goes to PA and PE. So if the token is actually, right, PE, it's going to go this way. P, it might like start following a different tree. And that's really what you're saying is happening inside the model, is how those things get broken up matters a lot for the paths that it follows. And then ultimately, right, that's kind of how you get context. It's how...
Exactly. Yeah, it's a way to outsmart the pre-processing layer of the model, essentially.
Right. So essentially the difficulty with it in terms of security relies on the fact that effectively these systems are by nature sort of split brain. And I think before we were talking, and I said that it's 2 different brains. One is at the textual level and one is at the execution level. And then you pointed out quite rightly there's actually three brains. There's also state. And so between state, between text, and between token, you've created this sort of split brain where if you put a security mechanism on one, you can an attacker can simply target the other two brains, right? That's the risk here.
It really is reminiscent of us trying to, like, use the lobotomy metaphor, but then now it's somehow split into three states where the mind has certain inputs that can filter across them, but they can't reason independently of them, right? And so what happens is at this pre-processing layer, you're able to use tokens and have it slip through, and they're preserving their semantic meaning to the underlying model because you've just divided the word up set in different new ways. You've just bypassed a internal check in that model's execution, and you got the meaning to the underlying model. And now it's like, oh, okay, I can do whatever you tell me to.
Oh, that's really interesting. So essentially, if you're looking at guardrails simply as a package of, for example, fancy regexes on inputted content to the prompt, then you're missing an entire couple of layers. So describe for us, I guess, how the other layers might be defended.
So generally my approach in thinking about this is in depth, and it's layering constraints. And like the very first thing is, I just go back to basics. Limit the number of acceptable inputs. If you can limit even the languages you allow a model to accept as inputs as a pre-filter stage, you vastly reduce your search space for detecting attacks. So like you're saying, we accept three languages: English, Hindi, and I don't know, Japanese. No other languages. Now we've tremendously reduced our search space. Tokens, ideally, you should just never let anyone provide raw tokens to your model, if possible. If you can remove that whole variation, you've further protected yourself. I think for most apps, that's not a concern, right? You're doing the tokenization yourself.
Yeah.
But expanding upon this, you do more and more layered approaches. Go ahead, Joel.
Yeah, I can see a few elements here that I think are areas of what I would call future expansion for security. One is inspecting token streams themselves. So you're already probably inspecting some of the prompt inputs, and you're absolutely right. You need to define the acceptable boundaries of which you will accept language surfaces and reduce the overall search space. That's definitely important. I think validating token sequences is another thing that could possibly be done, where if you're looking for common inputs, you want to make sure that they follow the canonical sequences and not the non-canonical sequences of tokens. It implies that we also have to have some sort of policy enforcement at the tokenizer boundary, which I know there's been lots of pushback about because it's definitely going to sacrifice performance in order to do that. And the other thing that might be of utility is once you know that you have certain trustworthy token flows, cryptographically sign them so that you can quickly validate them. Those seem like possible solutions to this problem. What do you think?
I mean, we're discussing two problems in two papers. This is the first one at the model level. I mean, really what it comes down to, in my mind, if you have the model file and you're providing such raw access to it, all bets are off. You can do anything you want with the model. It's more of a social contract that in how model providers are providing guardrails built in to keep those with less expertise from jailbreaking. Now, once you're talking about running models as a backend service and protecting them, it's a different class of problems in my mind. This becomes less of an issue because you can protect your token streams. And I like the cryptographic signing. So that means if somebody's hijacking one part of your system, and they start giving tokens to agents, um, you can reject them because you have another layer of security. That makes a lot of sense.
Yeah.
That's always been a good solution. And I like that you're pulling apart the two papers because like my attention goes to the token break because that's one, it's way easier to understand, I think, for most people what it's doing because there are analogies to previous, technologies. You mentioned in our pre-discussion, right? HTTP smuggling, right? You're really talking about
Right.
shoving code into an existing stream to smuggle it into the model and force it to execute. And that's what they're doing with tokens,
Yeah.
right?
Essentially, yeah.
Yeah.
It's making and you don't need this type of attack. You can also do post or pre-tokenization as well.
Yeah.
Um,
So yeah,
Go ahead,
let me
Joel.
just so everyone is very aware. From the two papers we're talking about, the adversarial tokenization, it does work, but it works only against open source models for which you have the ability to
Mhm.
investigate and debug, and you have access to something called logits, which for closed source foundational models, you don't have access to that. Those are things that are used to improve the model, and they don't allow access to that necessarily. But for open source models, it works really well. TokenBreak, the second paper, is an example of how to use a tokenization attack without necessarily having access to the debug infrastructure underneath. And it requires you send a whole lot of prompts through the model set in order to classify the responses that come back and figure out what the tokenization path might look like. Now, the bar for that attack is significantly higher, though, isn't it?
Yeah,
Yeah.
and it also requires a guardrails layer external to the model that works at the token level. Some guardrails work. You have to give them natural language prompts, and they do not take tokens as an input. Um, Specifically to get around this type or to avoid this type of exploit. Those still suffer from the same type of differential parsing attack. It's the same structural thing, it's just not working at tokens.
Right.
Um,
So practical advice, I guess right now of defending against these particular types of attacks is, first of all, if you are leveraging open source models, uh, make sure that no one has access to the logits, definitely. But if you're trying to defend against a token break attack, you're going to see indicators of this in what way? Lots of different prompts, things that look like they are trying to manipulate things like white space. That would be something that you would look for.
yeah, and predictable permutations of words.
Hmm.
This is where I go back to language detection as a first line of defense. Um, for example, every single word you prefix with a Z, um, smart models can figure this out, what you mean, but a lot of guardrails layers intentionally are designed to not use so much processing power. Um, so they're not as sophisticated as the underlying model. So this will just pass through the guardrails layer just fine, go to the backend model. The model can make sense of it, but the guardrails layer can't. And you can defend about this generally with language detection because it'll be like, I don't know this language. This is just
Hmm.
totally weird. This is in English, for example. And then it's
This
kicked
this
back.
This almost sounds like, brute force, right? Credential stuffing, but it's brute force prompt stuffing at this
Yeah.
point. So there are other ways, right? Behavioral ways that you can also identify, right?
Mhm.
Someone just like continually shoving prompts at a system.
Sure.
It could be an anxious, person just continuing to ask questions, but more likely an attack of some sort. So there's other
Well, I mean,
mechanisms
we've
to
talked about
detect
this
it.
before, and Elijah was exactly right. The only defense here is a layered defense, and we're going
Yes.
to have to
Yeah.
keep on adding layers to that defense as we go along. So one of the layers of the defense would be language detection. Another one might be anti-bot and anti-automation at the user agent level, to ensure that what the model is actually receiving through prompts isn't being automated, or you're slowing automation down to the point where these attacks are simply not practical, both computationally or economically. But again, these are basics. These are security basics that nearly all applications should have, not just the AI-driven ones. Layered defenses are going to get a lot more interesting from here on out, aren't they, Elijah?
Oh yeah. Oh yeah. I mean, the layers. I don't know if we're prepared for the number of layers that are coming. Um, One thought I had too about this at the guardrails layer is if you're using more sophisticated guardrails that are actually based on AI models as well, rather than just neural nets, this becomes less of an issue. They're
Mhm.
more capable of, say, detecting when someone's sending pig Latin or has altered tokens in some way as the input.
Right.
Um, and there's less differential between them and the backend model. There still is, but it's much harder to get a an attack through that will both bypass the guardrail and the guardrails of the backend model.
Well, the layered approach is also necessary in order to spread out the latency from each of these different, right, decision points where it's trying to decide, is this valid or not? Do I let it through or not? There's already, if you're working with, any of the AIs, there is a noticeable delay when your response hits a guardrail where it's trying to figure out, what am I supposed to do, and it churns and you can
Mhm.
feel it. It's the tell, right, that something is going on. And I think spreading it out, a layered defense, it sounds complex, like, oh, we have to have five different. Yes, you do, but the reason for that is also to spread out the latency and the cost, because you want to stop things like brute force right at the edge before it ever gets inside and costs more to do other things. And you layer it intelligently, strategically, in order to minimize both latency and cost to you and to compute, and you get a better system that is better well defended, I would say, at least. Yeah.
Yeah,
Well,
I think that's right.
and you touch on something that's a hard part of AI security, and that is supporting streaming,
Mm.
right?
Yeah.
And a
Hmm.
lot of streaming is just somewhat of an illusion for user experience. So it feels to the user like they're seeing updates, right? Things are actually coming in chunks and then it's being rendered like someone's typing it in. So you get to see it move across the screen, somewhat like a fancy progress bar. Um, Now, actually, though, working in chunks is a lot more difficult when you're using an guardrail external to the model. And so partly of what you're perceiving there is you're not able to smooth over those user experience issues as
Mhm.
well when you have more strict security constraints in place.
Interesting.
Good. Well, I and that's okay, right? To a certain extent, because we see them as thinking, we're a little more generous with, right, how much time it can take them. We're like, oh, it's thinking, it's okay, right? We tend to be more gracious, and not as impatient, which is good. But we're running up against time, so I wanted to move into kind of, right. What should someone take away from this, other than AI security is far
Yeah.
from done.
Oh,
What to do?
yeah. My takeaway from this is token aware security. We're reaching a future where that is no longer optional, where you're going to have to not only consider the text, but you're going to have to consider the tokens themselves and the streams of tokens that the text represents. We thought that prompt injection was purely about language analysis, and it turns out it's not. It's about representation and execution. The model doesn't execute sentences. The model executes token streams. And if your security is, if there is not a layer of your security that isn't able to see the stream, then you're already downstream of a potential attack. And so the future is going to include layered defenses at the token level.
Absolutely. Elijah, what would you want people to take away from all this information?
Well, what is old is new again. You have to protect your inputs. The terrifying thing about models is really they're a open-ended execution black box. You can pretty much entice them to create any sort of output with enough effort. And you have to reason about them from a security standpoint in that manner. That try as you might to enforce inputs, you may get arbitrary outputs.
Mm-hmm.
And you need to put constraints in to govern those outputs.
Sounds good.
Wow. Okay, so sanitize your inputs, which you should have been doing already, but hey, we're not judging. Sanitize your inputs and sanitize your outputs. Guard your outputs. Right, in and out.
Validate.
There we go. That's the word. Sanitize in, validate out. And there's going to be layers, lots and lots of layers, and it's important, right? We're not done. This notion of AI security being solved already, not even close. We're just getting started. So keep paying attention, keep evolving, keep adapting, and keep aware, I guess. So that is a wrap for Pop Goes the Stack. Follow this show so you're on call for our next forensic adventure. Until then, sleep with one eye on the logs and the other on the subscribe button.